Okay, here we go. Lesson 2.5. Please remember that you can watch these videos at any time at home. Okay, so as a quick review from 2.4, 2.4 involved you being able to do a compound inequality, and you would split it into two different math problems. Okay, a compound inequality, you covered up the front part of it, then you covered up the back part of it, you wrote the problem twice, and you solved both problems. So in other words, you had something like this: 336 is less than or equal to 3x plus 4, which is less than 528. Okay, so that would be a compound inequality. This is an AND problem. Why? Because it's all together. And then you have OR problems, and you know they're OR problems because they use the word OR. So we cover up one part of it, you'd write it once, you cover up the back end of it or the front end of it, and you write it again. So you'd have 336 is less than or equal to 3x plus 2, or 4, excuse me. And then you'd have 3x plus 4 is less than 528. You'd do both problems, and then you'd get your answer, and then you'd write your answer back into compact form. Alright, so that's what we did in 2.4. Now 2.5 is another way of splitting the problem. You have to know your opposites. Okay, so we've been doing problem solving, and everybody knows the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of squaring a number is to square root it. And then we're going to learn another one today. The opposite of absolute value means you split the problem into two. And we called this unzipping, because like when you unzip a jacket, it is in two pieces. Okay? But the pieces were the same when you zipped it as when you unzipped it. Hey, same thing with our linear equation. So we start with linear equations that have absolute values. Okay? And linear equations that have absolute values, we know when we graph them, they look like this. They look like the letter V. And the direction this V goes in determines whether the number in front of x is positive or the number in front of x is negative. If the number in front of x is negative inside of the absolute value, then that's what, or excuse me, I apologize, outside the absolute value, then it's this. Okay, so for example, 5x minus 4 would be a positive. It would look like that. And if it said negative outside the absolute value, then it would look like this. Okay, so let's do the first type, the linear equation, and we'll do the absolute value of 5x minus 4 is equal to 21. Okay, so in order to solve this problem, we treat it similar to a compact inequality, meaning we have to unzip this because the absolute value signs are telling me that the answer in here could have been positive 21 or negative 21. And the absolute value signs are the things that made it positive 21. So I have to solve two problems, one of them for a positive 21 and one for a negative 21, because that could have been the answer inside of these brackets, inside the absolute value sign. Alright, so I write it as 5x minus 4 equals 21, because I've unzipped it. Now, what I like to do is take this, and you can almost extend it and go, oh, I'm unzipping it, so I'm going to draw a problem there, just like your jacket. You unzip it and write two problems. Okay, so we have 5x minus 4 equals 21, And 5x minus 4 equals negative 21. Now in your book, they'll show it to you like this. This one was positive, this one was negative. And then they turn around and put the sign over here. I do not care if you skip that step. But understand, in your book, they show this step. I'm more interested in if you know that one answer could be positive 21 and one answer is negative 21. Well, Mr. Fraser, why do they show this step? Because you get rid of this negative by multiplying the whole problem by negative 1. And thus, this disappears from this side because two negatives make a positive. And over here, this positive then becomes a negative. But if you understand you're writing the problem and the answer goes from positive to negative, that's all I'm concerned with. Alright, and then the math is done for both problems. It's just the arithmetic that's different. So I add 4, I would add 4. And again, the arithmetic's difference. This is 21 plus 4, which is 25. And this is negative 21 plus 4, which is negative, correct, 17. Okay. Then of course this negative 4 is gone and you're left with 5x. 5x. You divide both sides by 5 and in this side you get x equals 5 and over here you get x equals negative 17 fifths. And that's an acceptable answer. You don't have to change it to a decimal if you don't like. You just write it as a division problem because fractions are division problems. Alright, so let's go ahead and look at a linear inequality. A linear inequality. Well, that means it has what in it? Correct. A linear inequality means it has a less than, greater than, less than or equal to, or greater than or equal to sign in it. The math is done the same. The arithmetic is actually even done the same. The only thing that changes are your signs. Okay, so instead of an equal sign, you have these signs. So let's look at a linear inequality problem. X minus 54.24. And I'm going to say is less than or equal to 1.43. So now I've had a linear inequality problem. Alright? And the linear inequality problems, or the absolute value problems, you can recognize them in words because you're looking for a change. So in other words, there's a target weight, or there is a maximum and a minimum amount of weight. You're looking for a range of things, and you can only be within a certain amount. Okay, we noticed that when we did the baseball analogy, or if you're trying to do the weight of a golf ball, or you're trying to lose weight and there's a target weight, and how much higher or how much lower can you be. Okay, we discussed this with your grades as well, that you have a range of possible answers. That's when you use an absolute value. Alright, so now we know when we use an absolute value or what kind of problems we write it in. Solving it is different than writing the equation. We can write the equation, now we're going to learn to solve it. So I have to unzip this. Okay, so when I unzip this one, I get x minus 54.24 is less than or equal to 1.43. And then I have to write it's negative. Now remember, this step, I've already told you, is in the book, but you don't have to do it. It's understanding that this can be positive and then negative. But here's the catch. When you're doing inequalities, if you change this sign, what happens to this inequality? It has to flip. So it would be x minus 54.24 is greater than or equal to negative 1.43. Notice, this sign changes, so this sign changes. And if you notice, if I write it like this, all the signs would change. Well, that's the rule. If you got to change this to positive, all the signs change. If you know it from the beginning, all you have to do is change this sign and this sign. And then you do the arithmetic, which is relatively easy, especially if you're using a calculator. So on this side I would add 54.24. On this side I would add 54.24. Notice, the math is the same, the arithmetic is changing. In this problem I'm going to have what? Well, let's see, 7, 6, 5, 5. This one's 5567, whereas this one, let's see, this one is... Let's make sure I get it right. Got 1.43 plus 54.24, and you end up with 52.81. So here you have a range of answers. Here x must be greater than this number, and x must be smaller than this number. So now I write it back in my compact form, which means I would go 52.81, 55.67. Why? Because I write the smaller one first, the bigger one second. And then, of course, my x is in the middle, because I know it has to be in between these. It has to be smaller than this, so smaller than this. It has to be bigger than this, bigger than this. Okay, so we've done compound equality, compound inequality. Notice, they're both done similar. There's only one rule that changes. It's when you make the negative of the second problem, you have to flip the inequality sign. All the rest of the math is the same. So now I'm going to go over a problem that has more than the absolute value sign in it. So I'm going to show you this problem. Why? Because it's the most complex problem you have, but it's not necessarily the hardest. So I'm going to kind of put it all together in one really hard problem, supposedly. All right, so in order for me to unzip this, I have to get rid of everything else other than the absolute value, meaning this has to be the last thing I see. Well, I also have to be able to read the problem. I'm supposed to add 5, and I'm supposed to multiply by 4. And when I do problem solving, I have to reverse everything, which means I'm going to subtract 5 and divide by 4. And then I'll be left with the absolute value signs and everything inside of it. So I have to get rid of everything outside of the absolute value first before I unzip. Okay? Alright, so I would minus 5 first, because I do everything opposite. Order of operations tells me to multiply and divide first and then add and subtract. I'm going in the opposite direction, and I'm doing the opposite math. Okay, so instead of adding 5, I'm subtracting 5. Because adding and subtracting are opposites. Alright, so this becomes 13, and I'm left with 4, absolute value of 2x minus 7. So now to get rid of this 4, I have to divide the whole problem by 4. Remember, the opposite of multiplying is dividing by the same number. Okay, when you multiply and divide, they're the opposites, not the signs. The signs are not opposite. It's just the math. So 4 divided by 4 is 1, obviously, so I'm left with just the absolute value of 2x minus 7. And on this side, I'm left with 13 divided by 4. Yay! Now, I can unzip my problem. And I would write 2. I can't unzip it until the only thing left is my absolute value signs and the equation inside of it. Now, I'm only going to unzip this one. I'm not going to continue with the math. Alright? I'm just going to unzip it. So this would be 2x minus 7 is less than 13/4. And then the other problem would be 2x minus 7. And what happens with my sign? It has to flip. Because I'm making this negative, this sign must flip. And that's the catch. That's the trick. The unzipping part shouldn't be difficult. It's only remembering that when it's an inequality, you got to flip that. Well, you can flip it if it's an equality, but hopefully everybody knows that when you flip an equal sign, it looks like an equal sign. So you can do it for equal signs too, but no one's ever going to see the difference. When you do it for inequalities, you see the difference. All right? And then you'd have to know your arithmetic. Now, what did we say was the shortcut of getting rid of fractions? If you want to get rid of a fraction, just multiply the whole problem by your denominator. So I'll just go ahead and do this problem anyway. I'll do this side. So I'm going to multiply everything here by 4. Okay? So 4 times 2 is 8x. 4 times negative 7 is negative 28. 4 times 13 divided by 4. The reason I'm multiplying by the denominator is so that I can get rid of the denominator. So I'm only left with the number 13. Because when you multiply by 4 and divide by 4, they cancel each other out. Now the rest of this looks familiar. You should be able to do it. I add 28. I have 8x is less than 31 or 41. I divide by 8 and I get x is less than 41/8. And I would do similar math on the other side. I'd multiply everything by 4, and of course I would get 8x minus 28 is greater than negative 13. Notice, the math is the same. The arithmetic changes because this is now negative. So when I add 28, it's actually subtraction. So you're left with 8x, and this is 15. And you divide by 8, and you would get x is greater than 15/8. So again, you could write this in compact form because it's going to be between those two numbers. So you're going to have 15/8. Hopefully you know that's smaller than 41/8. And your x is in the middle. And that's linear absolute value equalities and linear absolute value inequalities. All right, good luck. Okay, one of the last things that I wanted to share with you is that in 2.5, with your absolute values, you are able to determine whether or not it is an AND or an OR problem. If you have less than and less than or equal to, then you have an AND problem, which means you're going to have an intersection. It is going to be a conjunction, and your answer will look like this. Okay? You'll have something graphed that looks like that. If your absolute value problem when you start is greater than or equal to, these are your OR problems, which means your graph could look like this. Your graph could involve them overlapping and one being inside the other, so your answer would look like this. Okay, we've talked about this with OR problems. Or it could be all of the numbers and they overlap like this, and then your answer is all real numbers. Okay, so understanding that the inequality sign with your absolute value tells you whether you have an AND problem or an OR problem. All right, work well.